Yes.
For question 3, like, how do we know if it's A or B?
So let's look at questions from worksheet 5. Piecewise. So questions, we did a bunch, not a bunch, we did some together. Questions you have from worksheet number 5? Yes? Number 10. Let's do number 10. Alright, so the first thing we want to do on number 10 is notice that something's going on at 1, at x equals 1. That's the boundary, that's the wall. That's what separates the two sides from each other. So I like to draw the boundary line first. So we build the boundary there, and then on one side we'll put x plus 1. So when x is less than 1, we'll do x plus 1. And when x is greater than 1, we'll do 1/2 x cubed. So A and B. So x plus 1, let's see, that's a line. We'll begin at 1 with the y-intercept, and our slope is 1. So we'll begin at up 1, and with the slope of 1, we'll go up 1 over 1. The trouble is we hit the wall as soon as we go up 1 over 1. At the wall, for part A, is that an open circle or a closed circle? Closed. Part A owns the boundary here, so closed circle. And then I'm not supposed to keep going. Now, if 2 points isn't enough for you and you want to see what's happening, you want to keep going up 1 over 1 to sort of visualize the line, you can do that. Make sure you're in pencil because you're going to have to erase it later. So there's y equals x plus 1, but only in the right neighborhood. You don't want to be caught in the wrong spot. When x is bigger than 1, we'll graph 1/2 x cubed. So I know what the cube looks like. I'd squish it by 1/2. I think probably the easiest way to do this one is to just plot some points. So we'll start at 1. 1 cubed is 1 times 1/2 is 1/2. 2 cubed is 8. So half of that's 4. 3 cubed is 27. Half of that's 13.5. That's way off the graph, so we don't have much to go with here. So over 1, up 1/2. That's on the line, though. Open circle or closed circle for the graph of B at 1? Open. Graph B does not own that line, so open circle. Over 2, up 4. Over 3, up 13.5, so we're way off the graph at this point. So just super steep on that side. So think we're done. We step back, check, and make sure it looks right. When x is less than 1, so over here on the left, we graph the line y equals x plus 1. When x is bigger than 1, over here on the right, we graphed 1/2 x cubed, which sort of looks like this, but we only saw, and we cut off part of it, we only saw the right-hand piece of it. Question? Yeah. Thoughts on 10 or other ones you want to see?
Shouldn't we do like 1 to the left so it starts at the origin?
What's that you're looking at this point?
Yeah, like everything.
Well, I mean, yes, 0, 0 would be one of the points. And then 1/2 on the other side, and 2, 4. So like there's the rest of it, but that's in the wrong neighborhood, so I can't graph that.
Yeah.
But using the wrong neighborhood eraser method is certainly okay. If you want to see the whole graph and then be like, I need to throw away part of it, that's okay. Any others from the piecewise? All right then.